Hi judges. Yeah, the problem we are we are solving is trust the AI generators of the execution. Right? AI can generate code, scripts, workflow config, and agent action very quickly, but enterprise cannot blindly allow those artifacts to run and touch sensitive data, APIs, or payment systems. So our system treats every AI generated artifact as untrusted by default. By it becomes trusted only it becomes trusted only by passing a deterministic trust flow chain, hash hash evidence and policy token. All these workflows actually audit and revocation, right? So the UI only is a cockpit. It does not approve anything, so it does not show it does not show any. It does not approve anything. It only shows the backend trust state, right? How does this, transaction flow and the logs and its logs. So the backend is runtime REP. Backend decides the runtime REP enforces T3 terminal 3 protects outbound API actions. Audit T3 records proof. So, and AI says it is safe. The containment layer says prove it. Right? Our main tagline will be AI says it is safe, but the containment layer says prove it. Architectural summary. Let's dive into architectural summary. Okay, the system works layer by layer. The parser gate checks whether the input is safe and enter the trust. The hash prompts binds the artifact manifest parameter evidence and runtime boundary. Red team challenges the artifact using the adversarial personas. So here we are using around 60 personas uh, to check our softwares. And then blue team makes a deterministic allow or decision. So certification record trusted release eligibility. So and then runtime REP verifies the token bound execution token. Runtime REP verifies the and then protected action adapter checks whether the outbound calls are registered and hash. And terminal 3 auth protects sensitive outbound actions, and all the logs audit, the proof of allowed, deny, quarantine and revocation will be shown here in the audit and T3. Okay, so let's go now. I just marked some of the workflows actually. So first go with the first workflow. So it is executed cleanly, and it is the dashboard to show everything. So it is executed cleanly to show it's a happy path. So everything, all the all the gates has been passed. Okay, let's go with the second workflow, duplicate, right? If you see, the system rejects it before parsing, before the system validation, before the policy, before token, before runtime. Okay, this proves that bad input cannot enter the trust pipeline. This payload has the duplicate keys and malfunctional structural input. That is dangerous because the different parsers may interpret the same payload differently. So uh, next is critical red team. Critical red team challenges the artifact using adversarial personas. So here red team challenges the artifact. In our demo we show 60 personas enterprise baseline example. Red team does not approve execution, it only produces evidence. If red team finds critical failures, blue team consumes that evidence and blocks the artifact. This proves adversarial evidence have real enforcement impact. Right? So parameter mutation is blocked by REP. So parameter mutation blocked by here the artifact may have been approved for one safe parameter set but the runtime the parameters are changed. Runtime the parameter are changed. The runtime REP recalculates the parameter hash and detects the mismatch. So the execution is denied. This proves that nobody can approve a safe workflow and then execute a dangerous variation. Then let's go to the next workflow, which is runtime drift quarantine. So here the workflow may have passed earlier, but sometimes the changes during the runtime. Example, the dependency change, a config change, environment change, network or scope change, artifact mutation after verification. Runtime REP detects the drift and moves the workflow into the quarantine and termination. Right. So next is revoked and release. So here the release was previously trusted but later revoked. Once revoked, the old tokens are invalidated and runtime execution is denied. So next is the protected action. Protected action, this allows the terminal 3 protected action extension. So the workflow has already passed runtime REP, then it tries to call the protected output. The protected action contract matches, destination domain matches, path match protected hash matches, registered boundary matches, and terminal 3 auth allow, destination API is allowed. So this proves the clean external API path. So and let's go unregistered domain block. Then here is the runtime workflow may have executed, but it tries to call a domain that are not registered in the approved boundary. So the protection access boundary fails. The terminal auth is not even called. Destination API is blocked. This proves our system blocks unauthorized actions before it reaches terminal 3 or destination. Workflow, next workflow, change API path. So here is the domain may be correct, but API path has changed. Right? For example, the workflow may be approved for v1 reports. So workflow reports export, but it tries to call something else, like such as v1 payments transfer. So this protected hash does not match. So the destination API is blocked. This proves that we hash bind the exact API action, not just a domain. So then the terminal 3 auth denied, right? So here the runtime REP passes and the protection action contract matches, but the terminal 3 auth denies the outbound action. Because the terminal 3 auth denies, the destination API is not called. This proves that there are two separate gates. Our auth layer protects the trusted execution, terminal 3 protects the outbound protected action. The next workflow, okay, the revoked release action, blocked action. So revoked release blocked or the revoked protected action scenario, here is the release is revoked, the runtime execution is denied, and the protection action is also attempted. Terminal 3 auth is not called. Destination API is blocked. This proves that the revoked software cannot continue executing on call protected API. Right? So 14. This is audit 3. This shows the proof time. So T3 does not approve anything, and T3 only records evidence. So pending actor. So this gives us the proof of what is submitted, what is allowed, what was blocked, what was executed. So the key message is that this is not just an AI dashboard. This is a deterministic trust control layer for the AI generated software execution. We bind the artifact, approve and resource boundary, red team evidence, blue team policy, token runtime state, protected action, contract, revocation state, and audit proof. Only then the software will execute and call the sensitive APIs. So final line, AI generated software is untested by default. Our system makes it executable only after deterministic proof. That's all. Thank you so much. Babaji, Babaji.